Similar to the services in the previous module, we have the action server and the action client script here, as opposed to the service server and service client. Again, let's note here that this example script has been modified from the ActionLib tutorial on the ROS Wiki to suit this course context. So, the action server. First, we have all the relevant imports, including the action definition, feedback, and result message types. And we have a Python class implementation of the action server, which is also similar to the ActionLib tutorial. So, we first define the feedback and result messages here, and then we initialize the action server. We give it a name, and then we create a simple action server object which has this name and is of type counter with delay action type and processes the goal it receives in the execute callback function. Note that this execute_cb has the same meaning as the goal callback we learned in the earlier video on ROS actions. And let's leave the auto_start parameter as it is. Then we start the action server with the start function of the simple action server object. Now the execute callback function. We have the 1 second delay here and a flag to report on the result status. We then start the actual action execution. At first, there is always a check for preemption of this goal, and although we won't discuss it here, we will come back to this again in week 4, where we can understand why this is necessary in a better context. Alright then, we update the feedback and publish it. And after that, we wait for 1 second before the next count. Subsequently, if the goal succeeded, in this case it always will, we update the result accordingly. Finally, the main function. We first create a ROS node for the action server called counter_with_delay, and then we instantiate the action server implementation by initializing it with the name of the node. This function get_name actually gets the name of the ROS node, and that is exactly what will also be the name of the action server. Note that it is not mandatory to do it this way. Alright, now to the action client. We have the imports first, and then we create a simple action client to the counter_with_delay action server. Then we wait for the server to become available, similar to what we did in services. Then we create a goal message and we send the goal to the action server from the client. Now, like I said in the lecture video, we can include a blocking functionality in actions as well with the wait_for_result function, but we could as well just do other things while the action is being processed by the action server. And lastly, we return the result we received from the action server, which contains the result of executing the goal we just sent. And what is going on in the main function is pretty clear by now, just the creation of ROS node for the action client, calling the client function, and some relevant log messages. Okay, let's see some action in action. We start ROScore, then we start the action server with ROS run, and we see that the server has started. Then we start the action client also with ROS run, and as you can see, while the goal is being processed, we can do other things. Non-blocking execution, there it is for you. We can also verify this with the feedback message. We first echo the feedback topic and then go back and run the action client again. And now you can see there is a feedback about the action running, while the other application on the client side is also running. And just for completion, if we indeed wait for execution, then we first finish the action and then do the rest of the things on the client side, like we see here. Great. This concludes the action module. See you in the next module, which is also the last module for this week, where we will learn how to run multiple ROS nodes at once using launch files.